Alright, welcome to the first video in this pre-calculus review series. I'm just going to cover degrees and radians really quickly. I'm not going to spend too much time on degrees because I think we all know what degrees are. Just some integer range from 0 to 360 that represents represents any kind of rotation, with 360 being a full rotation and 0 degrees being no rotation at all. I don't know why we use 360 specifically. I believe that it's just because it's a highly divisible number, and when you're talking about splitting up a circle into different rotations, it just is most likely very beneficial to use a highly divisible number like 360. So, you know, if you want to quantify or split up a circle in units of, like, let's say, for example, 45 degrees, then you know that there's like 6 45-degree angles in a circle, or maybe you have like a 30-degree angle, right, and you want to know how many 30-degree angles are in a circle, something like that. And so these are all factors that are even factors of 360 that might just make it easier to work with and measure. So that's degrees. I think that was even longer than I wanted to talk about that for. But the main focus is going to be radians, and also converting between radians and degrees, but we'll get to that in just a bit. But I first want to recap what radians actually are. So one way of measuring an angle is by creating an arbitrary system or an arbitrary number like degrees. But another way is using an actual property, a fundamental property of circles, which is the radius. So every single circle has a radius, and the radius is always proportional to the circle. And so because of that, you can use the radius as a metric to measure around the circle, since it'll always be the same ratio, since they're proportional. So radians say that you can take the radius of a circle, we'll call it r, and you can stretch it along the circumference of the circle. One arc length is what that's called. So anytime you stretch something over a curve or a circle, we typically call that an arc length. And so the question then becomes, how many radii of the circle can you use to measure the entire circumference? And you're going to have to forgive my really bad drawing skills here. I'm using a mouse, so it's a bit difficult. But we should have 6 here. 1, 2, 3, 4, 5, 6. And then a little bit left over. So it's 6 radiuses that can go around the circle, and a little bit left over, and that little bit left over is 0.28 ... and if you take this entire value, then it is exactly equal to 2 pi. And so this is just another instance in math where pi just kind of shows up seemingly randomly. Pi is the common factor between the radius and the circle. So that's, as you get more and more precise measuring the circle with more and more radii, you start to approach this common factor of pi, which is a constant, and it holds true for all circles. So that's why pi is often referred to as the circle constant. And this is also why we use multiples or factors of pi to measure radians. So radians are always going to be basically in terms of pi. So that's just another important relationship to remember there. So 2 pi is a full rotation, so we could also say that 2 pi is equal to 360 degrees. So both of these represent the same thing. And we can also use this relationship to convert between these two, which I will try to cover right now. Alright, so luckily converting between degrees and radians and vice versa is fairly simple. It's literally just using the percentage formula, if you remember what that is. Basically, I'll give an example. If you have, let's say you want to know what grade you got on a test, you would take how many questions you got right. Let's say that you got 19 questions right out of 25 in total. If you want to find the percentage, what percent grade you got, you would take 19 divided by 25, and then you would multiply that by 100, right? So this is the actual ratio, or your percentage, and then we multiply by 100 because we score a grade from 0 to 100, right? So this is the most amount of grade you can get. So we multiply it by the maximum of whatever we're trying to find the percent of. So in this case, we want a percentage of 100. And then whatever that is our actual score. And I think I have that on my calculator here. So 19 over 25 is 0.76. And then times 100 is obviously just 76. So that would be our percentage grade. And we do this exact same thing. It's the exact same formula for converting between degrees and radians and vice versa. So let's say, for example, I have 30 degrees. And I want to figure out... Okay, I'm really bad at doing G's here. I want to figure out how many radians are in 30 degrees. So I want to convert 30 degrees into radians. So the first thing I need to do is find out what percentage of a full rotation 30 degrees is, right? It's just like finding out how many right answers you got versus how many questions there were in total. So I would do 30 divided by 360, and I can cancel these zeros out, and I know that this reduces to 1 over 12. And just like we multiplied our final percentage by 100 when we were trying to calculate our grade, in this case, we're not going to multiply it by 100, we're going to multiply it by 2 pi, since 2 pi is the maximum number of radians that we have in a full rotation. So, and the reason, again, why we can do that is because we know that 360 degrees equals 2 pi. I'm just going to put RAD for radians. And so this is why we can do that. So we would multiply 1/12 by 2 pi. And we know that this would reduce to 2 pi over 12. We can put that 2 into the 12. And this becomes pi over 6. There we go. So we know that 30 degrees is equal to pi over 6 radians. And just for completeness, I want to go ahead and give an example of converting the pi over 6 radians that we just got in our last example back into degrees using the percentage formula. So in this case, we're dealing with radians first, so we want to know what percentage of a full rotation in radians that pi over 6 is. So we want to take pi over 6 and divide it by 2 pi, which is our radians in question, divided by how many radians there are total, to give us that percentage. And we can reduce this or simplify this. I'm just going to put parentheses around this to make it a little less confusing. We can simplify this to pi over 12 pi. And we know that the pi's are going to cancel out. So pi over 6 all over 2 pi simplifies down to just 1 over 12. And in this case, we want to find the percentage of degrees. So of, again, meaning multiply, and degrees, we're working with 360 for degrees. So we want to multiply our 1 over 12 by 360, which is just the same thing as 360 over 12. And I just happen to know that this gives us 30. So we just went from doing 30 degrees into pi over 6 radians, and now this is how we do pi over 6 radians back to 30 degrees. Now, let's say that I wanted to make a function for converting these. So I could say, let's say that I want to make a function that outputs a value in radians when I input some degrees. So this is my input degrees, and this is my output radians. So that to that is equal to my degrees in question that I'm converting over 360, and then just times 2 pi. And the same thing, but in the opposite order for converting radians into degrees. So if I have degrees as my output, actually I'll use blue for degrees still. Degrees is my output, and my input is radians. Then that would be the radians that I'm converting over 2 pi times 360, since we're going from radians to degrees. And just for consistency here, not that it matters, because I'm about to move on anyway, I'm just going to color code that. So these would be the two formulas that you would use to convert back and forth. Again, I wouldn't even necessarily memorize these formulas. I would just memorize the fact that when you're converting between radians and degrees, it's just the percentage formula. So the only thing that I would memorize is, you know, like value over total times the thing that you want the percent of. So I would just memorize this, but that's totally up to you. Whatever helps you memorize it, I guess. Doesn't really matter. But that's going to be it for this video. Hopefully that helped. I think the next video I'm probably going to go into trig functions. But yeah, I don't think I have anything further to add to this video, aside from giving some more examples, but I think it's pretty straightforward from here. So, hopefully you enjoyed, and I'll see you in the next video.